Acid and base buffer solution. Buffer solution. Buffer solution is solution which has the ability to resist change in pH when a small amount of strong acid or strong base is added to the solution. It must contain acidic component where it can react with added OH- hydroxide ion, basic component where it can react with added H3O plus hydronium ion. Most common buffer component contain weak base and its conjugate acid. Conjugate acid come from salt. Weak acid and its conjugate base. Conjugate base come from salt. Buffer solution contain only weak acid or weak base. If the system contains strong acid or base, the system cannot act as a buffer solution. Type of buffer solution. Acidic buffer solution we prepared by mixing a weak acid and its conjugate salt. Acidic buffer solution with pH less than 7. Acidic buffer solution, it has two components. First component is component which is able to neutralize the strong base added to the buffer solution. Second component is component which is able to neutralize the strong acid added to the buffer solution. Component which is able to neutralize the strong base, example is weak acid. Component which is able to neutralize the strong acid is conjugate base or weak acid. Example, acetic acid and sodium acetate. Weak acid is acetic acid. Conjugate base of weak acid is acetate ion. Type of buffer solution, basic buffer solution. Basic buffer solution we prepared by mixing a weak base and its conjugate salt. Basic buffer solution a pH greater than 7. It has two components. First component is component which is able to neutralize the strong base added to the buffer solution. Component 2 is component which is able to neutralize the strong acid added to the buffer solution. Component which is able to neutralize the strong base is conjugate acid of the weak base, come from salt. Component which is able to neutralize the strong acid is weak base. Example, NH4 plus come from salt and ammonia is a weak base. How buffer solution control its pH? Example, we have a mixture of acetic acid and sodium acetate. Sodium acetate dissociates in water completely to produce acetate ion and sodium ion. Acetic acid dissociates partially in water, produce acetate ion and proton. The buffer solution of a buffer system contains acidic component, acetic acid, which is able to neutralize strong base OH- added, and basic component, acetate ion, come from salt, which is able to neutralize strong acid H plus proton added. Buffer solution control its pH. When a small amount of strong acid is added to the buffer solution, H plus acid added will react with acetate ion to produce acetic acid. Acetate ion remove or neutralize all the added H plus acid. As a result, pH remains constant. When a small amount of strong base is added to the buffer solution, OH- strong base will react with acid present to produce acetate ion, and water. Acetic acid remove or neutralize all the added OH minus. As a result, pH remain constant. Basic buffer solution. Example, we have mixture of ammonia and ammonium chloride. Ammonium chloride dissociate completely in water to produce ammonium ion and chloride ion. Ammonia dissociate partially in water to produce ammonium ion and hydroxide ion. The buffer solution contains acidic component NH4 plus ammonium from ammonium salt, which is able to neutralize strong base, OH minus added, and basic component ammonia, which is able to neutralize strong acid H plus added. Buffer solution control its pH. When a small amount of strong acid is added to the buffer solution, strong acid H plus added react with ammonia to produce ammonium ion. Ammonia remove or neutralize all the added proton. As a result, pH remain constant. When a small amount of strong base is added to the buffer solution, OH minus from strong base react with ammonium ion to produce ammonia and water. Ammonium ion remove or neutralize all the added OH minus strong base. As a result, pH remain constant. Henderson-Hasselbalch equation is equation to determine pH of buffer solution. Acidic buffer solution. pH equal to pKa plus log concentration conjugate base over concentration weak acid. Example, we have a mixture of acetic acid and sodium acetate. pH equal to pKa plus log concentration conjugate base acetate ion over concentration weak acid acetic acid. Basic buffer solution. POH equal to pKb plus log concentration conjugate acid over weak base. Example, we have a mixture of ammonia and ammonium chloride as a buffer solution type basic. POH equal to pKb plus log concentration ammonium ion as a conjugate acid over concentration ammonia weak base.